We had a question on 2258. 2258 starts out with this compound and says that this is going to react with aluminum trichloride and then with HCl and a zinc mercury amalgam. And then it gives you an NMR spectrum and an IR spectrum and says, show what the product is, show a mechanism, and explain in terms of those spectrum. So let's first think about what actually would happen in this reaction, because we can get most of the way just from the reaction conditions itself. The first is aluminum trichloride. This is the catalyst that's required for things like Friedel-Crafts alkylation and Friedel-Crafts acylation. Because we already have an acyl group here, we know that this chlorine is going to complex to the aluminum and create a much more positive charge here that can react with the ring. When we react with the ring, we know that this is the only group on the ring, and so it can direct to the ortho or para positions, but we also know that if we attach here, we would have a ring that's 1, 2, 3, 4, 5, 6 pieces. If we attached here, it would be the same ring. There's no difference between those ortho positions. And if we attach at the para position, the ring would be very difficult to form because of steric. And so we know that we're probably going to form a 6-member ring attaching at this position. We can verify this with symmetry that we see in the product NMR. So we have this aromatic ring. We'll go through our normal Friedel-Crafts acylation mechanism, and we'll create a ring that now looks like this. We'll maintain aromaticity on the original aromatic piece, but we'll have this piece joined on like this. This carbonyl is still reactive, but these conditions are for a Clemmensen reduction. And so when we go through this HCl and zinc mercury amalgam piece, that will allow us to remove the carbonyl and end up with just the straight aromatic with alkane piece. Some of the things that we can look for to verify that this is the type of product that we'd see: we don't see a carbonyl peak, so we can look to see that there are no highly shifted, above the aromatic region of NMR peaks. So the aromatic region is around like 6 to 7, and we don't see any NMR peaks above that. We can see that we have 2 different types of protons here, one set here and one set here. We see 2 sets of alkane-based protons in the NMR peak. We also see 2 pieces in the aromatic. Oftentimes those blend together, and we see a total of 4 protons by the integration that's in the NMR. And again, these blend somewhat together. So that also makes sense. We can also look at the IR. We should see no carbonyl peak in the IR, and that's also true. If you look close enough in the fingerprint region, you can look for this type of ortho substitution peak in the aromatic peak. That's a little bit further down the line, but we're pretty sure this is the product already.